complex numbers. You guys had this in Algebra 2 pretty much at the same time last year. The imaginary number, or imaginary unit, this I, which represents that square root of a negative 1. So if that is my I, the square root of negative 1, excuse me, my I squared is just going to be negative 1, absolutely. I cubed. Well, my I cubed, I can write this way. I squared times I. What is I squared again?
Negative 1 root.
Which is a negative I. Right? The law of exponents, right? I'm just adding my exponents, right? So, and for my I to the fourth, I can rewrite it as what? I squared, which is what? So here, this is I to the fourth. What about I to the fifth? Again, use your law of exponents, right? I to the fifth. I to the fourth is what? 1. 1 times I is just I. What about I to the sixth? Negative 1. What about I to the seventh? What about I to the eighth? It's just going to repeat itself, folks. Right? It's going to start off with my I squared being negative 1, then the negative I, and the I to the fourth. So we can talk about I to the 47th if we needed to. Right? We're just looking at, if I divided it perhaps by 4 and look at that remainder. Yeah, so I to the 104 or 103 would be the same thing as I to the 3. Right? So utilizing that, we can simplify. No longer are we just talking about real numbers, folks, right? So no longer can you say it does not exist. Now there is a solution when we have a negative inside a square root. So here I have the square root of a negative 16. So what do I get? Alex. The square root of negative 16 is what? What times what? Square root of 16 times a negative 1. Square root of 16 is?
4. Wait, says it 4i?
Oh, absolutely. As Ali said, we wind up with 4i. Square root of 16 is 4. Square root of a negative 1 is just I. Michael. What about square root of negative 25? Square root of 25 is left behind at negative 1, which we know is by definition just I. Sophie, square root of a negative 27? Okay, well, again, but there's still something with that 27. Absolutely. As Sophie said, it's 27, and that negative, we have that I, absolutely. But now we need to take care of that square root of 27. 3 square root of 3i. Some of you may decide to write as 3i square root of 3. Same thing, just make sure that you clearly indicate that that I is not underneath that square root. So in other words, if you want to write it as 3i square root of 3, that way it's safe, you know, hey, that the I is not underneath that square root. All right? Either way is perfectly fine, as long as you indicate you know that I is not underneath that square root. And a square root of negative 20.
2 is square root of 5i.
Absolutely. All we're doing is taking the square root of 20, 4 times 5. Give me that 2 root 5. And the negative left behind is just my I. 6i squared. There we go.
Negative 6.
How'd you get that?
The I squared is equal to negative 1.
Absolutely. So again, I said that I squared is equal to negative 1. So 6i squared becomes just a negative 6. Likewise, Alexander, for 15i squared?
Negative 15.
Nothing complicated about complex numbers. No pun intended. Negative 4i squared for Harry?
4.
Absolutely. Negative 4. My I squared negative 1. Negative 4 times negative 1 gives me that positive 4. I'll do that tough one there. Negative 9i squared. Negative 9 times, again, by definition, I squared is just negative 1. So, Stephanie, yours looks a little bit different here. Square root of a negative 14 times the square root of a negative 2.
Do you put them together?
This is something that, since imaginary numbers are not real numbers, we have to define the operation, so to speak. When you're dealing with imaginary numbers, first you have to simplify, pull out any i's. Unlike the real numbers where you're absolutely right. With real numbers, I can just multiply the radicants together. That doesn't work with imaginary numbers. Imaginary numbers, before we multiply the insides, we have to actually take out the negatives. So, first things first would be what? So if you take this out,
Yeah.
you wind up with what?
Negative square root.
We get 14, square root of 14i, right? Yes? What do we get with the second term?
Square root of 2.
Square root of 2i. So now when we multiply, what do we get? Square root of 14 times square root of 2.
28.
So square root of 28 I squared. Okay, what is the square root of 28?
Square root of 7.
My I squared. So here we come up with a negative 2 for 7. If you take a look at this, if instead you decided to start off with multiplying, what would happen? Absolutely. So you're going to turn into a positive. I have negative 14 times a negative 2, winding up with a positive 28. And then we'd come up with our answer as being 2 square root of 7 versus the negative 2 square root of 7. Again, since this is not a real number, it's an imaginary, we have to define how the operations work. So what about this one? Negative square root of negative 27 minus negative square root of negative 12. Jonathan.
I think on the I, so you've got square root of 27i minus square root of 12i.
Okay. Just the i's?
I don't know.
Can't, when I'm adding or subtracting, can I just do it with any radicals, or do they? They have to be alike. So right now, 12 and 27 have nothing to do with them. So what else can I do? Okay. So where do we get that?
Got 3.
Okay. So 3 root 3, and you said we already took out the I. Minus?
Minus 2 root 3 up.
Absolutely. As John said, first simplify here. Now I actually have like terms, right? I have 3 of something minus 2 of something, which is going to give me 1 of something, right? And what is that something? Absolutely. Yes.
Should we write it I squared?
Yes. As I said before, like in this one up here, right? If you want to write the I before the square root, you can do that. You can do that so you can make sure that it's understood that I is not within that square root. And lastly, we have this minus 2 plus square root of a negative 5 quantity squared. Joe, what should we do here?
Take out an I.
That sounds painful. Quite a bunch. So, oh, this is, just think of,
Can we will?
absolutely, so, just like we would with any binomial squared, as Joe said, just FOIL it out. So when we FOIL it out, what do we get?
4.
Sorry. Why minus 5? Absolutely wrong. You're absolutely right. I'm going to show a little work for you. But no, Joe, you're absolutely right. So, collector-like terms. And as you already pointed out, we have minus 5. 4 minus 5. Minus 4. Or if you wanted, again, minus 4 I squared. Again, we're doing the exact same stuff that you do with real numbers. As far as adding, as far as multiplying, subtracting, we do the same things, but now I've introduced I. When you see I, usually when you see that negative in the square root, you pull it out, it becomes an I. I squared becomes negative 1. Yes, question.
Oh, yeah. So I don't get why whenever you do the square root of negative 5 squared, why does it become hard?
Right. Or if you want to think about it, right, as far as when we did it before, if you remember, the I, you have to first pull out the negative. So we have I square root of 5 times I square root of 5. Square root of 5 times square root of 5 is 5. I squared, that's my negative.
Right. Okay.
Again, defining the operation of imaginary, not necessarily the same as what we do with real numbers. So that being said, we do come up with a definition of our complex number. So if A and B are real numbers, the number A plus BI is a complex number. Written in standard form. That's why in the last case, in the last example we did, it was written as negative 1 minus whatever, because we're first going to have the real part, and then we're going to have the part dealing with our I. If B equals to 0, what's going on with our number A plus BI now? Absolutely. The BI part is gone, and I just have A, just a real number. If B is not equal to 0, call A plus BI an imaginary number. And if my A is 0, excuse me, if my B is 0, A is 0. If A is 0, right, we just have the BI. And if b is not 0, this bi portion is just a, what we call, not just an imaginary number, but a pure imaginary number. And all this is just a terminology, right? As far as I can have a real number that is actually a complex number, right? This is where my b would be 0. So underneath that complex numbers, I have real numbers and imaginary numbers. Yes? So what does this all look like? Well, here, if we want to write the complex number in standard form, Mario, we have that 4 plus square root of a negative 9. How would I write this? So what is the square root of a negative 9? 3 what? So there's 3 from the square root of 9 and the negative 1 from that I. Now what? I want it in standard form, so what do? I go to the next problem. A plus bi.
Oh.
It's already in standard form. Standard form, right? The real part plus the imaginary part. All right. What about the next one, Galina? We have 2 minus the square root of a negative 27. Okay. Anything else? Absolutely. Absolutely. 2 minus, whether you do, again, 3i or 3 square root of 3i. I have my a and I have my b. Right? My a in this case, positive 2, my b a negative 3 square root of 3. And last one. Miriam. This one looks a little bit different. What should I do with the 6i? Nothing to do with 6i. That's just a negative 6 times I. There's nothing to do with it, right? But what about that I squared? Am I done? Absolutely. Now we have it again. This would be incorrect, of course. This is not in standard form. Standard form, first the real, and then the imaginary. Everything we're doing here, folks, most of these, the commutative, associative, distributive laws of real numbers, it also applies to my imaginary numbers. So when I'm adding or subtracting, I'm going to wind up with the same stuff. When I'm adding a complex number, what am I going to add? I have a plus bi plus c plus di. This is the same thing as doing what? Collecting like terms. So what am I adding together in this case? Absolutely. My a and c. And what else? Absolutely. I'm adding my real number with my real number, my imaginary part with my imaginary part. When I'm subtracting, am I doing anything differently? Okay? So what would I get?
A minus.
Absolutely. So I'm subtracting my real ones. And with imaginaries?
Yeah.
Absolutely. Subtracting the imaginaries, subtracting the real ones. Again, folks, this is the exact same thing as if we were to simplify and say collect like terms, isn't it? Nothing different. So, if we have something like these, Monica, I have 7 plus 3i plus 5 minus 4i. What am I adding? Absolutely, absolutely. I add the real numbers together. So I'm adding the 7 and the 5. In my imaginary, I have a 3i, and I have a minus 4i, which gives me that minus I. Tough stuff, right? Tommy, what about the next one?
Then E plus 6i. We're going on.
Absolutely. As Tommy said, negative 3 plus 6i. The 3 minus 5 gives me that negative 2. And 4i minus negative 2i. Tommy said that gives us that plus. Yes.
So why aren't you subtracting the 4 and the 2?
Well, we did. All right, this would be, so I have my 4, then what, minus, right?
Yes.
Minus what?
2.
A negative 2.
Oh.
Right? So that's why we come up with the negative 2 plus 6. Because this is the minus. This just, always think of this as it's in the form of a plus bi. So my b is actually a negative 2. So that I'm subtracting, my b is a negative 2. All right. E5. This one looks a little bit different. How many terms do we have here? How many? 3. I have my 4i, I have my minus 3 plus 5i, and 2 minus 6i. When I'm adding subtracting, my associative laws hold true for addition with my complex numbers as they do with real numbers. What was the associative law? You want to remember? It's how we associate. In other words, if I have A plus B plus C, which ones do I add first? Doesn't matter. Can I do A plus B and then plus C? Or can I do B plus C and then A? Same thing with complex numbers. The grouping doesn't matter, but we can go ahead and perhaps tackle these guys first. So what do we get here first? So what is the real number here? You guys agree with that? That's it. Yes, it's an understood 0, right? Since this is a pure imaginary number, I have 0 for A. So 0 minus a negative 3 gives me that positive 3. 4 minus 5 gives me that negative I. So now what are we going to do? Now I have same type of problems before, right? We just add. 3 plus 2. Absolutely. 3 plus 2 for my 5, my real part, my imaginary, a negative 1 and a negative 6. Giving me that minus 7i. Yes? What about the next one, Raphael? So for these guys? Okay. Okay, so what is this one?
5 plus 3.
Which is?
8.
Uh-huh.
Plus 3. Plus
Absolutely. Absolutely. 5 plus 3 gives me that 8. Negative 1 plus 4 gives me that plus 3i, which equals, so everything's going to cancel out, and we just wind up with 0. Questions? Concerns? As I said before, all the properties hold true for our complex numbers and one of our lines. Right? My associative, my commutative, my distributive laws, right? Distributing an I, distributing a real number, distributing a negative. Associative, commutative, all those properties hold true with my complex numbers. So when we're multiplying complex numbers, we go ahead and use those same laws that hold true for real numbers, such as, again, the distributive law. So in this particular case here, I'm going to distribute my 8i. Distributing the 8i, 8i times 4, 8i times a minus 3i, 24 what? Am I done? What is I squared? Absolutely. Negative 24 times the negative 1, using the positive 24, and again, we want to always write it in standard form, a plus bi, giving us that 24 plus 32i. What about the next one, Francine? Absolutely. Go ahead and FOIL it out. All right? So if we FOIL it, what do we get? Absolutely. Just like we would with real numbers with two binomials, right? FOIL it out. And now just simplify. What is this term? Absolutely. I squared being a negative 1, that's a positive 4, along with my
19.
Just making sure you guys are paying attention. So 15 plus 4 gives us a 19. 12i minus 5i gives us a 19 plus 7. Complicated stuff, right, folks? Come on. Here we have 2 plus 4i times 2 minus 4i. Four plus or 4 minus? Over here, what do we have here, folks? Very good one. We have ourselves a difference of squares. So we do know, as Mike said, we're going to have that first term squared. There isn't going to be any of that middle stuff at all, is it? It's just the first term squared minus my second term squared. So 4 minus 16i squared, which is the same thing as right, because my I squared of a negative 1, giving us, here we multiplied two complex numbers and wound up with a real number. All right. What about this last one here? You done? Okay. And if it's helpful, what should you do? Write it out. Don't try doing all of it in your head, right? So what do we get? I guess we're waiting for the final answer. No, I want to know you're working up to it. So 25 minus, okay. All right. So what is my 99 squared? What's that? Yeah, it increased. It's not Friday yet.
Yeah.
Which gives us? Questions, folks, other than where did that other zero come from? Can't come from anywhere, folks. It's zero. If you notice in this last one, or not the last one, but in the 2 plus 4i times 2 minus 4i, when we multiplied those two together, we came up with a real number. In other words, we made the complex numbers disappear. Having that relationship, those two numbers, we actually call those complex conjugates. When you can multiply the two together, you can get rid of the complex number. The only thing with the complex conjugates, right, they have the same A, the same B. The only difference was what? The signs, the plus and the minus. Again, these are called complex conjugates. Just a name here. So I have A plus BI and A minus BI are complex conjugates of each other. They behave such that when we multiply them, complex number disappears and I line up with this, a real number. So, here I want to multiply each of the complex numbers by its conjugate. What do I do here, Brooke? What is a complex conjugate of 3 plus I? Absolutely. So now that, again, the way that complex conjugates behave, these are the difference of squares. So all I have to do is what? So square the first one, 9, minus my last term's. This becomes a difference of squares, which is just the first term squared minus the last term squared. Absolutely. So 3 squared minus I squared. There is no outer, there is no inner, there is no middle terms at all. That's what makes the complex conjugates work when we multiply. So 9 minus I squared, or 9 minus what? Negative 1. If you chose the right number for your complex conjugate, you always will come up with a real number. 5 minus 4i, complex conjugate is? Multiplying, we get what? All right. Absolutely. First term squared minus last term squared, so 25 minus 16i squared. Question? No, you can ask. Oh, question over here.
I was wondering what the last slide was, like the film length.
So 25 minus 16i squared becomes what?
25 plus
What? Okay, I thought I heard 4. Tough numbers there. Questions? This is about as difficult as it gets. And again, we're not doing anything new here, are we? We multiplied, FOIL, distributed, used all that stuff before, but now we've introduced I or I squared. The only thing is, when you're doing quotients, when you're doing fractions, you don't want to have your A plus BI complex number in the denominator. So when we're writing a quotient of a complex number in standard form, we need to somehow get rid of that denominator that's in the complex number and make it into a real number, perhaps. So how do you get rid of a complex number? Multiply by its multiplied by its complex conjugate. So multiply numerator and denominator. By the complex conjugate of what? Numerator or denominator? Denominator, because that's the one we want to get rid of, right? So and I do top and bottom, why? Does it make life difficult?
Yes.
That's why you do choose a bottom.
Absolutely, because in fact all I'm doing is multiplying by 1. Right? So whatever that denominator is, find the conjugate, multiply numerator and denominator by it, using your FOIL or double distributive. And the last step, always simplify. So here we have 2 plus I divided by 2 minus I. What number am I looking at to come up with a complex conjugate? Okay, so what is the conjugate then? So multiplying top and bottom by that conjugate, 2 plus I. So on the top, FOIL it out, right? 4 Absolutely. 3 times 2, 4, plus 2i, plus another 2i, plus I squared. Right? In the bottom, I have my difference of squares, right? Absolutely. 4 minus I squared. Yes? Giving me what? Over what? Absolutely. 4 minus a negative 1, 5. Am I done?
And you can get rid of the bottom.
I should know better, right? I was simple minded. Is that in standard form?
No.
How do I get it in standard form? How can I multiply? I don't have an equation.
Three over five. 3 over 5 plus 4.
You guys are overthinking it. Absolutely. It has to be in the form, right? A plus BI, my real number plus my imaginary part. So definitely, this 5 is underneath both terms here. So 3/5 plus 4/5, 4/5 I should have said. Yes? And lastly, 2 plus 3i divided by 4 minus 2i. Which conjugate am I using here? Looking at the denominator, absolutely. So 4 plus 2i. Now FOIL out, or double distribution on the top, giving us what? 4 plus 2, 4 times 2. Plus 4i. Yes, no?
Yes.
And after doing all the simplifying in the top, so look, my 8 and my 6i squared just becomes a negative 6. Giving us 8 minus 6, or just 2. And my denominator, 20. questions? Question. Did we learn anything new here? No, not really. All I did was introduce I and I squared. Everything else you've done before, right? The multiplying, distribution. So, on here, you're doing numbers 6 through 54 every other even. Okay, if you want to do every even, so the red line crossing on out, but then 60 through 64 even. This